I'd like to start things off and say thank you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the Fisher Technic Education Division over here at Studica. And as you can guess, today I'm going to provide you with an overview of Fisher Technic's line of pre-assembled industrial simulation and training models, including the very latest models, such as the ones you see on this picture, incorporating new cutting-edge technologies. So just to give you a little bit of an introduction, over the years, I would typically begin these presentations with a discussion of the importance of STEM education, uh, talking about changes in the manufacturing environment and the growing need for highly skilled workers in the modern workforce. But at this point, I think it's fairly well established just why technology-focused education is so necessary. I'm going to dispense with any preamble and pretty much jump right into the discussion of what Fisher Technic is, and I'm going to show you each of the current models that are available in the simulation family. Fisher Technic simulation models have been designed with the intent of providing a compact, engaging, and a hands-on method for teaching and demonstrating high-end automated systems. Now, the line consists of a series of pre-assembled small-scale models which are designed to replicate both in appearance and in function various automated robotic machines and systems that are commonly found in commercial manufacturing. Now, before we look at each of these models, I'm going to provide you just with a little bit of background on what Fisher Technic is. Fisher Technic has been creating tools for teaching students of all ages how technology works for over 50 years, all based around their unique building system. Now, what makes this building system unique is that unlike many popular construction systems where the components are designed to simply stack, Fisher Technic was created with more of an engineering mindset. The core building block, which is the one that you see on your screen right now, is designed to enable attachment from all six sides, and because of this, it allows for almost limitless design possibilities. Many of the parts in the system are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts available will also help technical builders to address very specific design needs. The Fisher Technic system was created back in the 1960s by German inventor Arthur Fischer, who you see on the screen now, and he's known for countless innovations used in both the construction and the automotive industries. Mr. Fischer, at the time of his death back in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, prior to creating Fisher Technic, Mr. Fischer was also first noted as the inventor of synchronized flash photography, and this was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. I'm sure anybody who's done any kind of home repair or hung anything heavy has had to use one at some point. His company, the Fisher Group, continues to employ thousands of workers around the globe, producing many variations of fastening devices used in building construction. And they also produce numerous components used in automobile assembly, as well as providing consulting services to companies who wish to employ state-of-the-art manufacturing processes. Now, once again, the focus of Fisher Technic building sets, and it's whether those that are intended for the retail market or for classroom use, in either case, it's always been designed to help foster an understanding of technology and how things work. Many of the products offered by Fisher Technic for the education sector are what we would call subject-specific sets, focusing, for example, on different STEM-related topics such as mechanics, pneumatics, robotics, renewable energies, and so on. Now, many of these sets either include curriculum or detailed teaching and activity materials, and in most cases, students are being asked to build a progression of different models using the Fisher Technic system, and then they perform various experiments which allow them to explore and understand key aspects of that subject. Now, the line of Fisher Technic simulation solutions, which are, of course, the focus of today's presentation, are something a lot different. The line consists not of kits, but these, again, are pre-assembled small-scale models which are designed to replicate in appearance and function various automated robotic machines and systems. Some of the models that you'll find in the Fisher Technic simulation line include things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even a high bay warehouse storage system. Now, besides these individual models which focus on specific automated processes, fischertechnik also offers several variations of an integrated factory simulation model. Now, in these factory models, they consist of multiple workstations. In most cases, you're going to see things like a vacuum gripper robot, a high bay warehouse storage, a multi-processing station with an oven, and a sorting line with color detection, sometimes with other components added in, but designed to all work together as one self-contained material cycle. And we're, of course, going to look at all of these models as the course of the presentation moves on. Now, before we do that, let me very briefly outline some of the advantages of advantages of using fischertechnik solutions. The first advantage is fischertechnik simulation solutions allow educators to offer engaging, hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this could be for understanding how automated systems work, or for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate, and that's both in appearance and in function, common automated systems such as conveyor belts, sorting machines, robotic arms, and much more. Because the models are compact and in most cases tabletop size, they are not only ideal for use in the classroom or in office demonstrations, but also for demonstrating software or other technology-based offerings in a trade show environment. The next advantage is quality. Each fischertechnik simulation model is a hand-assembled, high-quality German-made product. Each model is available in a 24-volt version for industrial users, with select models also available in a 9-volt version for those not versed in the use of PLCs. The 24-volt versions are designed for use with industry-standard PLCs. Now, it doesn't matter whether you use Allen Bradley controllers, if you like Siemens controllers, or if you prefer controllers from manufacturers like Honeywell, Mitsubishi, General Electric, you can pretty much name it. Whatever you choose, you can control these 24-volt models with the PLC you prefer. Likewise, just as you can use your choice of controller, you can also use your choice of the preferred programming languages, which you see listed on the screen now. Now, please note that with these 24-volt versions, in most cases, unless I specify otherwise, no PLC is included. And in most cases, again, unless specified otherwise, all programming and programming guidance, as well as any power sources or other hardware, are going to be the responsibility of the end user. So in most cases, again, you're going to be giving the model. So if there's any additional wiring, additional components, again, unless we mention otherwise, which there will be a few instances of it, you would have to provide that. Now, of course, this shouldn't be an issue as these models are designed specifically for industrial users or for those teaching or exploring industrial processes involving PLC programming. Now, as I touched on before, though, if you're not involved with PLCs, there are also 9-volt versions available as select models. Now, these 9-volt versions will ship pre-wired to fischertechnik's own proprietary robotic controllers, which are the Robotics TXT controllers and the Robotics TXT 4.0s. And in the case of these controllers, each controller is pre-programmed either using fischertechnik's own RoboPro-graphic programming software, in some cases C, C++. The only additional component required with these 9-volt versions will be the addition of one or more 120-volt power adapters, as I will specify when we discuss these models. Otherwise, in most cases, these 9-volt models should essentially be ready to use right out of the box. Now, if you're involved in demonstrating or exploring IoT, basically the Internet of Things, besides the fact that many end users have adapted some of the models in the primary line of simulation and training solutions to use for IoT purposes, fischertechnik now also offers a few select models that are IoT-focused versions of the factory simulation, designed specifically for exploring and understanding cloud control and what is often referred to as Factory 4.0. In the case of these models, they're designed to be both controlled and monitored from a special web-based dashboard. And we're, of course, going to discuss this in more detail a bit later in the presentation. The final advantage I want to discuss is that fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are in the marketplace, You'll probably notice pretty quickly that the entry level for many of these products can easily be $30,000 to $40,000 or much more. It's not unusual to see things that are $90,000 or $100,000. Fischer Technic simulation solutions, on the other hand, start at just a fraction of this price. And again, they're also compact, realistic, and high quality learning and demonstration tools. So on that note, let's look at each of the models which are available. And we're going to begin to look at some of the more basic modules, and we're going to work our way up to the larger factory models and some of the newer models that are available, which again consist of several individual workstations designed to showcase an entire production cycle. But before we get there, we're going to start off with the classic line of Fischer Technic simulation models, and our first is a basic conveyor belt. In this case, this is a transport belt with a length of 275 millimeters that is used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as you may desire. Components on this model include an excess motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 14 by 10 by 4 inches, and it has a weight of just about 2 pounds. The model is available in both 24-volt version with a multi-pin connector. That would be 26 pins with a 2.54 millimeter grid as seen here. And again, the 24-volt version of this model, as well as all but one or more of the 24-volt versions we're going to look at this afternoon, there's been a couple modifications, will require you to provide the PLC and the programming. Now, there's also a 9-volt version of this model available, which is connected to a pre-programmed robotics TXT controller, as shown here. One 120-volt power adapter is required for operation, and I will mention that for this and for all the models we're going to look at today, the specs are also detailed in the product listings found on the Studica and fischertechnik.biz websites, as well as in our product brochure, which I will provide information on obtaining at the end of the presentation. The next model we'll look at is the punching machine with conveyor belt, which is a variation of the conveyor belt we just looked at, except this time with a machining station built into it. Components on this model will include 2 excess motors, 2 push-button limit switches, 2 photo transistors, and 2 LED light barriers. Dimensions of the model are approximately 15 by 12 by 7.5 inches, and it has a weight of just about 3.5 pounds. Again, it's available in a 24-volt variation with a 26-pin connector and a 2.54 millimeter grid as shown here. And the 9-volt version comes wired to the robotics TXT controller, which again requires one 120-volt power adapter for use. Next up is the indexed line with 2 machining stations. This model features a U-shaped conveyor line consisting of a milling and a drilling station along with 4 conveyor belt sections. Other components on this model include 8 excess motors, 4 push-button limit switches, 5 photo transistors, and 5 LED light barriers. The dimensions are approximately 19 by 18 by 11 inches, and it has a weight of just about 8 pounds. Again, it's available in both the 24-volt version with a 26-pin connector and a 2.54 millimeter grid for use with PLC of your choice, and a 9-volt version wired to the pre-programmed robotics TXT controller. And again, actually, this one will require 2 120-volt power adapters. Next up is a variation on the idea of a pick-and-place robot, which is called the 3D or 3-axis robot. The 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the work pieces it picks up in 3-dimensional space. The degrees of freedom for the robot are as follows. Axis 1 can turn 180 degrees, Axis 2 can move forward or back 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components in this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions of the model are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. Now, as with the other models we've looked at, this is again available in both a 24-volt version with the 26-pin connector and 2.54 millimeter grid, designed for use with the PLC and the programming of your choice, or a 9-volt version wired to a pre-programmed robotics TXT controller and requiring one 120-volt power adapter. Next up is the vacuum gripper robot. And in this case, we get to see some video of it. Now, as you're going to see here, the vacuum gripper is a 3-axis robotic model with a vacuum gripping device. And the model is designed to precisely pick up and position workpieces in three-dimensional space. The model here includes 3 encoder motors, 3 push-button limit switches, a vacuum suction device, a compressor, and a solenoid valve. Its dimensions are approximately 9 by 19 by 15 inches and has a weight of just about 7 pounds. The 24-volt version of this model, as well as all of the 24-volt models we're going to be looking at moving forward in this presentation, each have a relay board for motor polarity reversal and both a multi-pin connector. In this case, we're going to start looking at 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, the 24-volt version of this model, as with all 24-volt versions, will require you to provide the PLC and the programming of your choice. There is not a 9-volt version of this currently available. We'll let this play through. And there we go. Now, moving right along, the next model we're going to look at is the automated high bay warehouse. The model you're going to see here features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays, along with 9 individual storage spots for the pieces. Components on this model include 2 encoder motors, 2 mini motors, 4 push-button limit switches, 2 photo transistors, 2 LED light barriers, and a selection of different colored workpieces along with carrier trays for each piece. I will mention that this model is a favorite among educators that I've spoken with who are involved with teaching PLC programming. The reason for that is because it gives students a lot of very specific coding tasks that they need to address. Things like, of course, the precise movement of the picker arm, the storage and retrieval of the work pieces from the shelves, which of course requires a fair amount of precision, and so on. Getting back to the model itself, the dimensions for the model are approximately 19 by 28.5 by 15 inches, and it has a total weight of about 18 pounds. Again, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. Again, you need to provide the PLC and the programming. There is a 9-volt version currently available, which ships pre-wired to a pre-programmed robotics TXT controller, and that requires one 120-volt power adapter. Next up, we are going to look at the multi-processing station with oven simulation. Okay. The model you're going to see here features a furnace simulation with a pneumatic sliding door. There's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper, a cutter with a rotary table, and a conveyor belt. Components used on this model will include 4 mini motors, 6 push-button limit switches, 2 photo transistors, 2 LED light barriers, 4 solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of just about 11 pounds. Again, it's available in both 24-volt versions for use with the PLC of your choice, with, once again, a relay board for motor polarity reversal, and both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. The 9-volt version in this case is connected to 2 robotics TXT controllers, so if you do get that one, you will need 2 120-volt power adapters for all operations. Let this play for a second. And there we go. Whoop, jumped the gun there. The next mile an hour progression is the sorting line with color detection. Check here. Okay. The simulation you're going to see here features a system for detecting work pieces of different colors, and it sorts them via conveyor belt into 3 different storage bins. Components on this particular model include 2 mini motors, 5 phototransistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for the model are approximately 20 by 14 by 12 inches, and it has a weight of about 10 pounds. Now, as stated before, again, the 24-volt version has a relay board for motor polarity reversal, and both the multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And again, the end user must provide the PLC in the program. The 9-volt version of this model will come pre-wired to a pre-programmed robotics TXT controller, and in that case, one 120-volt power adapter is required. We'll let this play through the sorting real quick. And I think it's good to see the individual stations and focus on these, because we're going to start to get into the factory models where they incorporate a number of these. So the next thing we're going to look at is the factory simulation, the basic factory simulation. And this combines the last 4 models which we reviewed. Again, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and of course the sorting line with color detection. It combines these into one self-contained material cycle. And the cycle you're going to see in the video ahead works like this. Work pieces are retrieved from the automated high bay warehouse using the vacuum gripper robot, and then they are moved to the multi-processing station with the oven. After the workpiece has been processed by this machine, it's then sorted by color in the sorting line with color detection before being again moved by the vacuum gripper robot to the automated high bay warehouse for storage. Now, as we've already discussed the components of each of these individual stations previously, I'm not going to belabor it by restating them here, but what I do want to mention are the dimensions of this model as a whole. As it again combines 4 individual models into one work cycle, because of this, it has a much larger footprint, in this case, 39 by 31 by 16 inches, and the total weight is between 43 and 46 pounds, depending upon whether we're talking about the 24-volt variation or the 9-volt variation. Now, due to these dimensions, and again, because these all come pre-assembled, please note that these factory models, all of the factory models we're going to look at today, can only be shipped flat as freight on a pallet. This would be the same thing if you're going to be transporting these yourself. You always want to ship these and transport these flat. Preferably if you're shipping them using a shipping service, they have to be shipped as freight on a pallet. I also want to point out that as the factory simulation models can be in high demand, especially during the summer, you might want to anticipate a 2 to 3 week turnaround prior to any orders for this model leaving our warehouse, and the same would go for the other factory models, especially the newer ones. A few other things to note. First off, this is again available in both a 24-volt version and a 9-volt version. In the instance of the 9-volt version, it's wired to 5 robotics TXT controllers, and because of that, it's going to require 3 120-volt power adapters. As with all the previous models we've discussed so far, the 24-volt version will require the end user to provide the PLC, the programming, and any other hardware or wiring required. Now, before we move on to the next group of models, I do want to mention that there is a storage option available for those users of either of the 2 factory simulations we just looked at who might need to transport the model or protect it when not in use. And that's, of course, the travel and storage case. The travel case itself consists of an aluminum casemaker profile with plastic plates and steel ball corners, as well as 4 steel tilt handles and angle protection corners. The upper section of the case is partially lined with soft foam blocks in different heights to help cushion the model, and it also has 3 internal zipper pockets for storing cables and other accessories, workpieces, etc. The lower portion is lined with hard foam, and it's designed so that once the top of the travel case is removed, the model can remain in the bottom section of the case and be fully functional. So this way you can just take the top off, put the top back on when you're ready to go, and you're all set. The case itself has exterior dimensions of approximately 41 by 33 by 17 inches, and the weight of the case alone is about 53 pounds. So essentially, if you're going to have a model in the case, you're looking at about 100 pounds of weight there. Please note, though, that even when using this travel case, models would still need to be shipped flat or stored flat. But if you're shipping it, always ship it on a pallet, whether in the travel case or not. This will protect it from any possible damage at transport. Now, the next group of models we're going to look at focus on the area of IoT, and these are what they call the Training Factory Industry 4.0 models. This group of models was designed to help address how the recent changes in industrial production, which were driven by digitization, have created a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the existing factory simulation model that we just looked at, you're going to see that such digitization activities can be simulated, learned, and applied on a small scale, of course, before they're implemented on a larger scale. Now, as this video that you're going to see now does have a nicely narrated overview of all the specifics of how the factory works, I'm going to step back for a moment and allow you to watch and listen to the narrator. Oh, I'm hearing that we aren't getting sound. My apologies here. Let me make a correction. You're going to see the screen disappear for a minute. Christy, we're going to need to redo the screen share, so be prepped for that, however we do that. Let's see here. If you can help me with that. Let's see. Let's see. You're still not getting any sound, Christy? because there's a little click you have to do there. Yeah, is the, let me see if, I apologize to our attendees for a little sound dropout. Yeah, there's something that needs to be clicked at the bottom there. Otherwise,
technology
Recording in
ensures material.
Okay, that's good. All right. Nope, we seem to be boom, boom, boom. Oh.
Fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first-in, first-out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. The material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Again, my apologies for our little sound snafu there. But just to summarize things quickly, here are some of the topic areas which can be addressed with the fischertechnik Training Factory, Industry 4.0. Of course, training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices, using and operating dashboards, web-based remote maintenance, linking of production and materials in planning data, connection of upstream and downstream logistics processes, and for experts, the creation of your own unique programming using C, C++. As you just saw, this model incorporates many features not found in the models that we previously discussed, perhaps most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be the camera that you saw, which is used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure. The use of NFC chips in each workpiece enables the position of the workpiece to be in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, allows the network TXT controllers to communicate with one another. Now, in regard to the 24-volt version specifically, I should note that it is a little bit of a hybrid in that while requiring a PLC for operation and control, it does also incorporate one fischertechnik Robotics TXT controller. The TXT controller in this case serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. OPC UA, also known as OPC Unified Architecture, is a standard for exchanging data across different platforms. In addition to the TXT controller used here, there is also an IoT gateway using Raspberry Pi with Node-RED. And this allows for the option of not only presenting and using data on a dashboard in the fischertechnik cloud, but also being able to display data and calibrate the stations of the factory in a Node-RED dashboard. The model also incorporates newly developed 24-volt adapter boards to interface to the PLC. And these, of course, ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, this latest generation of adapter boards allows for the speed of the encoder motors to be controlled via PWM or pulse width modulation. And they also have push-pull output stages for photo transistors and for buttons. Now, unlike the previous 24-volt models that we've discussed, the new 24-volt Training Factory Industry 4.0 model includes access to a sample program. And in this case, the program is created in structured text format, and it's created based upon a Siemens S7 1500 PLC. And this program is available for download on GitHub. Of course, the new training factory can also be controlled with other PLC models and brands once the end user makes small adjustments to the sample program. And the source code needed for this is also available for download for free from GitHub. All of this information and much more is included in the 152-page PDF manual, which is designed for this model, which can be downloaded from the Fischer Technic website, and it's also available from us directly upon request. So at the end, you will have information on how to connect with me. If you want to see the manual for this or the other models, just let me know. I also need to mention that as of last year, there are also 2 additional versions of the 24-volt model which are available. And I'm going to discuss those 2 options when we get to the pricing end of the presentation. But there are 2 more options on this that we're going to look at. Now, in the case of the 9-volt version of this model, the control is facilitated through the use of 6 robotics TXT controllers. And again, in the case of the 9-volt models, all programming is preloaded. In this case, it's C, C++. So that once the connections to the internet and the cloud-based dashboards are made, all of which is clearly outlined in the downloadable documentation PDF that accompanies this model. Once you've done that, you should be able to get started pretty quickly. So the 9-volt model is about as close to a turnkey version as you're going to get. And in the case of the 9-volt model, it will require 3 additional 120-volt power adapters that are sold separately. Not an issue there. Now, it should go without stating that whether we're talking about the 9-volt or the 24-volt versions, it is also required that the end user, of course, has the ability to access the internet, and that you also have a tablet or a device, a laptop, what have you, for accessing the cloud-based dashboard. Just to finish things up, the dimensions for this model are approximately 39 by 31 by 16 inches. It has a weight of approximately 51 to 53 pounds, depending on which version. And as with the 2 factory simulation models that we discussed previously, we do recommend the optional travel case to help protect your model during transport and storage. And that's the Training Factory Industry 4.0 model, again, available in both a 9-volt and a 24-volt version. The next model we're going to look at is a relatively new model. It incorporates the cutting-edge technology that is quickly becoming a part of our daily lives, and that's it's AI, of course. So this is the quality control with AI system model from Fischer Technic, and it's ideal for visualizing this complex subject area in a hands-on manner, as it creates a sustainable learning experience by linking theory and practice. Processes can be sped up, fault rates and costs minimized, and fault evaluation standardized. This Fischer Technic sorting line variation comes with workpieces in 3 different colors, but these workpieces are also marked with 3 different processing characteristics, as well as various fault patterns. Now, the workpieces will get scanned by the camera, and they're classified with the aid of the trained AI. Now, depending on the color, the feature, or the fault pattern, the workpieces are then sorted by the artificial intelligence on the basis of the quality features. The AI used is realized with machine learning in TensorFlow, where an artificial neuronal network was trained with image data. The learned AI is executed on the Fischer Technic TXT controller. The model sequence control is implemented in the programming environment and also in Python. Now, if you want to go a step further, you have the option of generating your own AI applications, and in this case, the training is done in Python, for which a sample project is provided for explanation. And that's essentially the new quality control with AI model. Ideal training, simulation, and demonstration model for education and research, and also for the visualization of AI systems, machine learning, and neural networks. Right now, this is only available in a 9-volt variation, but we expect the 24-volt version to be available later in 2024. In the case of this 9-volt version, it uses the Fischer Technic's Robotics TXT 4.0 controller, and as stated before, a 120-volt power adapter is required for operation. Now, we have one more model to look at, and I'm just going to get a drink of water first. What you're going to see here is the agile production simulation. And this is the very latest iteration of the factory model, like the ones we just looked at, this time not only incorporating IoT and state-of-the-art manufacturing processes, but also AI, and this time with a digital learning platform included as well. This factory of the future is the subject for numerous research projects in science and industry. Forward-thinking companies rely on automation, modularity, artificial intelligence, and agility to remain competitive. So in order to promote these topics in industry and research, students, apprentices, as well as employees require the corresponding know-how and awareness to deal with these complex issues. This is where the learning concept agile production simulation comes in. It simulates processes such as quality assurance using artificial intelligence, the functioning of driverless transport systems, and replicates automated processes on a small scale, from the goods receipt to modular production to quality assurance. The accompanying learning materials translate the hands-on simulated processes into future skills for both students and teachers. And the digital twin of the model significantly intensifies the learning experience. Now, as we do not yet have a narrated video of this particular model because it's brand new again, I'm going to provide you with a quick overview, beginning with the module where incoming and outgoing goods are placed. And that is, of course, where the material flow of a workpiece begins and ends. The raw material in this case is delivered to the goods receipt slot, positioned on the color sensor for quality control using the 6-axis robot with a vacuum gripper, and then it's encoded on the NFC reader. The robot then places the workpiece on the automated guided vehicle, or the AGV, for further transport. The module also contains the central control unit, in this case the Raspberry Pi, and the environmental sensor, which measures the different environmental conditions in the factory. There is also an integrated movable camera which can be swiveled in 2 axes and provides an insight into the entire factory via the fischertechnik cloud-based dashboard, which of course we saw an example of in the previous factory video. At the end of the cycle here, a finished workpiece is delivered at the goods dispatch by the AGV. The next stop for a workpiece after goods receipt is most often the high bay warehouse, although because this is an agile production simulation, that could differ if there was a need for doing so. But in any case, the high bay warehouse contains, again, as you saw before, 9 slots for workpieces. It has the stacker crane and a vacuum gripper that picks up the workpiece, in this case from the AGV at the docking station, and hands it over to the stacker crane for storage. The workpiece is placed in a workpiece carrier for storage, and retrieval is done according to the first in, first out principle, of course. Next up is the drilling station. The drilling station consists of a docking station for the AGV, a vacuum gripper that places the workpiece onto a conveyor belt from where it is transported under the drilling head. After the simulated drilling process occurs, the workpiece is transported back to the gripper on the conveyor belt, and the gripper then places it back onto the AGV. Next, it goes to a milling station. The milling station consists of a docking station for the AGV and a vacuum gripper that places the workpiece onto a conveyor belt from where it is transported under the milling machine. Then the milling of 2 pockets is simulated. After the process, the workpiece is placed back onto the conveyor belt and transported back to the gripper. The gripper then places it back onto the automated guided vehicle. The next station is the quality assurance station with AI. In the quality assurance module, a vacuum gripper places the workpiece on a conveyor belt. It is transported underneath the camera and scanned there. The workpieces, in this case, come in 3 different colors, of course, red, white, and blue, with 3 different machining features: drilling, milling, or drilling and milling, as well as various fault patterns, and they're all classified using the trained AI. Now, depending on the color, the feature, or the fault pattern, the workpieces are then either placed back onto the AGV as okay, acceptable goods, or sent to the reject container as not okay or defective. And the AGV vehicle we've talked about transports the workpieces from one module to another. It's a track-bound vehicle that follows the printed black tracks that you see on the screen. and it uses ultrasonic sensors to detect obstacles. The vehicle has Omni wheels, which allow it to move in all directions. Two buttons and a photo transistor help the vehicle dock to individual factory modules. The AGV receives its driving commands from the central control unit, in this case an industrial standard VDE 5050, and it uses a fischertechnik rechargeable battery pack as its power supply. There's also a charging station, so when the battery of the AGV runs low, it navigates towards the charging station, where it is automatically charged with a charger with charge monitoring. Contacts on the bottom of the charging station connect the AGV with the charging electronics. Just to give you some specifics on it, the power supply is, of course, 24-volt power supply unit with 11 amps. Central control is done with the Raspberry Pi, Raspberry Pi. It's a long day. Raspberry Pi 4B. The individual modules are controlled by 5 SPS Siemens S7 1200 PLCs. That's a new thing. There are 3 TXT 4.0 controllers for sensors and cameras, as well as cloud access in the WEWA module for quality assurance with AI and for automated guided vehicles. And there is also a WLAN router for WLAN network. Looking at the software, there are SPS programs in structured text. There's TypeScript for central control on the Raspberry Pi. There is Node-RED for communication between SPS and the TXT 4.0 controller. There's Python for programs on the TXT 4.0 controller. And there's TensorFlow for supervised learning and quality assurance with AI. Now, again, there is also a digital learning platform with a digital twin of the APS model so that learning can be done with both the actual model as well as in a virtual environment. Now, we're going to have more details on all of this, as well as other aspects of the new model, along with a video of the model in action, available very soon in a separate presentation, and we hope to announce this very shortly. But at least for now, this gives you an overview of the Agile production simulation. I will mention that we do have brochures on this that I'd be happy to send you in PDF format, and again, at the end of the presentation, I'll give you information on contacting us, and we'll be happy to send you that. So it's been a while, so you've probably been wondering how much these models might cost. So we're going to take a quick review of each of the options we've discussed, along with the pricing for each. Looking at the conveyor belt, in the 24-volt version, these are $354.95 each, of course, requiring the PLC and the programming. The 9-volt version that comes with the TXT controller is $518.95. When you're looking at the punching machine with conveyor belt, the 24-volt version, again, requiring PLC and programming, is $464.95. In the 9-volt version with the TXT controller, it is $599.95. The indexed line with 2 machining stations in the 24-volt variation, again, requiring your PLC and programming, is $1,199.95. In the 9-volt variation, which does have the 2 TXT controllers, it is $1,394.95. The 3D 3-axis robotic arm in the 24-volt version, again, PLC and programming required, is $1,059.95. In the 9-volt version, with the TXT controller and the pre-programming, it's $1,369.95. The vacuum gripper robotic arm, currently only available in the 24-volt version for requiring PLC and programming, $1,199.95. The automated high bay warehouse in the 24-volt version, $1,448.95. In the 9-volt version, which comes with the TXT controller, it is $1,318.95. Multi-processing station with oven in the 24-volt version is $1,287.95. In the 9-volt version, which comes with the TXT controller, $1,474.95. The sorting line with color detection in the 24-volt version is $1,126.95. In the 9-volt version, $1,128.95. The factory simulation in the 24-volt version, it is $5,149.95. Again, this requires the PLC and programming provided by the end user. The 9-volt version is unfortunately, as I look now, currently unavailable. So only a 24-volt version on the standard factory. This is, of course, the non-IoT, non-AI version. The Training Factory Industry 4.0, this is the one that incorporates the cloud-based dashboard. In the 24-volt version, requiring the PLC and the programming, is $9,498.95. This is the same price in the 9-volt version, which comes pre-wired to the pre-programmed robotics T controllers, and that's $9,498.95. But there are new variations available as well. There is a version of the Training Factory Industry 4.0 24-volt, which includes the PLC connector board, as you see here, and the cabling. This version is $12,718.95. And there is another version, a Training Factory Industry 4.0 version, which includes the cabling and the connection board, as well as the Siemens S7 1500 PLC. There are two price variations available on this. If you are in education, if this is being purchased for an accredited institution, it is $19,319.95. If it is for commercial use, private use, it is $20,124.95. So again, just to review there, with the PLC connector board, you're looking at $12,718.95 for the Training Factory Industry 4.0. If you need the variation with the Siemens PLC S7 1500, again, that is $19,319.95. For the EDU variation, or $20,124.95 for the commercial variation. Again, all of these models will include access to the program that was created in structured text. So you get that. Other items to look at here, since I've touched on them, the 120-volt power adapters, they're $12.99 each if those are required. The training and storage case specifically for the Training Factory simulation and the Training Factory Industry 4.0 models are $1,524.95 each. The quality control with AI model that we looked at, only available in a 9-volt version currently, that is $2,249.95. That comes with the TXT controller. One power supply is required. No 24-volt version available yet, but we will hope to have that later in the fall. And finally, the Agile Production Simulation in the 24-volt version, only available in 24-volt version. Again, this includes 5 Siemens S7 1200 PLCs and 3 TXT 4.0 plus the digital twin. This is $28,174.95. There is also an Agile Production Simulation storage case that is available. This is $4,024.95. And essentially, this is a much larger 2-tiered variation of the case that we previously looked at for the other factory models. And in this case, it's designed to house the various components in modular sections of the APS model. And that's another thing about the APS model. It has a much larger footprint when put together of basically about 51 inches by about 73 inches. So it has a larger footprint. Because of this, it comes in modular sections like giant puzzle pieces that each contain a different module. And those can be put into the case here when not in use or when in transport. Again, we recommend with all factory models, as well as with this new model, that whether you use the storage case or not, the model should always be shipped flat on a pallet to avoid any damage to the models. Again, the same specs apply with the plastic plates and the steel ball corners and what have you. And again, you're looking at a cost of $4,024.95 for that. So at this point, it's a lot of talking, a little bit of a snafu there, but if you do have any questions, this would be the time I would ask you to tap or to type them into either the question and answer window or the webinar chat window, both of which can be found on the Zoom toolbar. If I don't say anything coming up, I'm going to move right to the next screen because I know we're moving along late. If you'd like to take the next step, if you'd like to request the full color brochure that we have those in PDF versions, or if you'd like to receive a printed version, we can send it to you as well. But if you'd like to receive the full color brochure on all of the models, if you'd like to receive the information specifically on the new APS model, that's all available. If you'd like to ask us any questions, if you'd like to receive a quote, a formal quote for any of the models you've seen. If you'd like to speak with your dedicated educational representative, if you're in a specific state, we would put you in touch with the educational representative for your state. If this would be a commercial request, you would be speaking to me. In any case, you can contact us here. Our number toll free is 888-561-7521. General inquiries, if it's an educational customer or if you're an educational customer, you have general inquiries about connecting with your rep, what have you, or if you need a quote, you can email us at info@studica, studica.com. If you do have any questions specifically for me, anything I touched upon, didn't touch upon, that you'd like to discuss, anything you want to know about Fischer Technic in general, or anything specific we looked at today, you can contact me as well. My email, of course, is lance.zurek, lance.zurek @studica.com. So again, I thank you very much for bearing with us during the sound difficulties, and we thank you very much for taking the time to attend, and we look forward to hearing from you soon.